Hello everyone, welcome to fraction of problems. I call them fraction of problems because they're fractions of sets, they're fractions of groups. So we're going to show you a couple different ways, actually two ways that we do this in the classroom, and let's get started. So we start off with ones that they can easily identify in their head, like 1/2 of 20, and I'll say to the class, okay, what is 1/2 of 20? Well, they know right away 1/2 of 20 is 10. And I go, well, let me show you how this trick works here. 1/2 of 20. One way we can go about doing this question is circle that bottom denominator and put a times sign there. Because we're going to break it into two groups, and we're just basically doing an algebra problem. We've been doing algebra all year. 2 times what gives me a 20? And they go, okay, 2 times 10. So there's the number we're using, and then our numerator tells us how many groups of 10 we care about. How many groups of 10 do we care about? We care about one group of 10. So 1/2 of 20 is 10. We look at the same thing over here. Circle that denominator. Let's turn it into an algebra problem. 1/2 of 100. Well, 2 times something gives me 100. 2 times 50 gives me 100. And how many 50s do we care about? We care about 150. So there's our proof that this technique works. But we can always do halves. Halves are easy. When it gets a little bit more complicated is when we start changing that denominator, and it gets really complicated when we start changing the numerator on you. So let's test our technique out on some other problems. So I have 16 students. 1/4 are going to pass 4th grade. How many are going to pass 4th grade? Well, I have 16 total students. 1/4 of 16. That's a fraction of problem. Let's turn it into a multiplication problem. 4 times what gives me a 16? Okay, 4. So that means 1/4 is 4. How many fourths do we care about? Well, luckily here, we only care about 4. So how many students are going to pass 4th grade? 4 out of the 16. It was a rough year. Let's try it out on some other problems here. Let's try it out on 1/5 of 25. 5 times something gives me a 25. 5 times 5. And how many 5s do we care about? We care about 1 5. So 1/5 of 25 is 5, and that makes sense. If I took a 25 and broke it into 5 groups, 5, 10, 15, 20, 25. I have 5 groups of 5. Now, we're really changing it on you because we're going to change the numerator, but we'll show you how this works. We're going to use the same trick we've been doing the whole time. 8 times something gives me a 16. Well, 8 times 2 gives me a 16, but now, how many 2's do we care about? We care about 3 of those 2's. Well, 3 2's, 2, 4, 6. 3 2's is 6, so 3/8 of 16, if I had 3/8 of 16 apples, that would be 6 apples. Now, we have our 2 wise men down below here, and we give you some interesting fractions. And we ask, what is interesting about this answer, and what is interesting about this answer? Well, let's try our technique again here. 6 times something gives me a 36. All right, 6 times 6. And how many 6's do we care about? We care about 6 of them. So 6 6's. That is 36. But what's interesting about that? Well, they're the same number. But that makes sense. 6 6's is 1 whole. If I eat 6 6ths of a pizza, I've eaten 6 of all 6 pieces. Right here, if I have that same pizza cut into 36 slices, I ate all 36 slices. So I've eaten the whole thing. That makes sense. So there's our first wise man. Our next one, 5/4 of 20. Let's use our same trick. 4 times something gives me a 20. 4 times 5. And how many 5's do we care about? We care about 5 of them. Well, 5 times 5, 5 groups of 5 then, is going to be 25. What's interesting here? Well, this is our whole group. We have 20 apples, 20 pies, whatever. We're going to eat 25 of them. how does that make sense? And we look and we go, well, actually it does make sense because that's the fraction they're showing us. If this was 4/4, kind of like this was 6/6 over here, that would be the whole thing. 36 is 36. If this was 4/4, I would expect 20 to be 20. But because this is 5/4, it's a little bit bigger than one whole, I expect my answer to be a little bit bigger than the whole group. And we call this one an improper fraction, im meaning not, it's not proper. And we learn that as we go along in our fraction unit, we're not allowed to leave fractions like that, and we kind of feel uncomfortable because we look at other fractions and you're not supposed to be top heavy. That's why it's improper. It doesn't feel right to look at. That's what improper is. It's a top heavy fraction. And we learn that all improper fractions are always going to be bigger than the whole group. They're bigger than one whole group. That is our first way of doing fractions of sets.